In this video, we're going to do an example of integration using partial fractions where we have a repeated linear factor in the denominator. So we're being asked to anti-differentiate x squared minus 5x plus 16 over 2x plus 1 times x minus 2 quantity squared. Since we have that repeated x minus 2 factor in the denominator, we know that the partial fraction decomposition will be just a constant over 2x plus 1, but then we need a separate term in our decomposition for every power that we have for the repeated factor. So in this case, since we have a repeated factor with a multiplicity of 2 here, we have two terms that correspond to the x minus 2 factor. One is to the first power and one is to the second power. And again, since we have a linear factor that we're doing the decomposition over, the numerators will be constants. So that's why it's just b and c there for our numerators. Clear our fraction, so we get the equation x squared minus 5x plus 16 has to equal a times x minus 2 squared plus b times x minus 2 times 2x plus 1, and then plus c times 2x plus 1. This is a statement about polynomials, so it has to work no matter what we plug in for x. Plug in a negative a half, we'll knock out the b and the c terms here. We'll get the equation 75 fourths equals a times 25 fourths, so your a has to be 3. Put an x equal to 2, we'll knock out your a and your b terms. You get the equation 10 equals 5c, or c equals 2. We still need another equation to figure out what b needs to be. And we don't have any more quote-unquote good numbers to plug in because we've already plugged in what makes those factors 0. So let's try equating certain terms. Let's equate constant terms here. That is equivalent to putting in 0 in for x. We get the equation 16 equals 4a minus 2b plus c. We already know what a is, we know what c is, so plugging those values in and solving for b, you'll get b equals negative 1. So now we're able to replace the integrand with 3 over 2x plus 1 minus 1 over x minus 2 plus 2 over x minus 2 squared. Antiderivative here for the first term will be 3 halves natural log of 2x plus 1, adjusting for a 2 in the denominator because we got that 2 times the x there, if you think about your u substitution. Antiderivative for 1 over x minus 2 is just natural log of x minus 2. And then the last term, again, we can think of this as a u to the minus 2. Its antiderivative would be a minus u to the minus 1. So we get a negative 2 over, this should be x minus 2 here, not a 1. That should be a 2 in the denominator. So you should have a minus 2 over x minus 2 plus c.